Hi, in this video I'm going to help you get started with the Creality Sermoon S1. Creality has released a new software version. Okay, and this is where you can download Creality Scan for 1.1.17 from this website, which is compatible with the Sermoon S1. It's the first version that supports the S1. There are still some issues here and there, but first start, you will need to calibrate your Sermoon S1 by connecting it to the USB-C cable that comes with the scanner. You can now connect your Sermoon S1 with the Wi-Fi handle, but you cannot calibrate the scanner. You will need to connect it to the cable to calibrate it. The calibration that they made from the factory has some issue, and it has to be recalibrated with the software version 1.1.17 to work correctly. So I highly recommend that you need to calibrate this before you start using it. When you first plug in your 3D scanner, it's going to update the scanner firmware, and if you click here on the setting, click on the firmware update tabs, you will see this tab, device sound. After you update your firmware, scanner sound will be disabled by default, and if you want to turn it back on, you need to click on here. I like the sound to be on because when I switch between the scanning mode, I want to be able to hear some response that it has been switched. This is your calibration board, and it's made specifically for your 3D scanner, so it's come in a pair, and it also has a QR code in the back that tells the differences between the other, so you cannot break or lose it. Okay, first you need to click on the calibrate here, and because I have already calibrated this before, but if you haven't, it will ask you to scan this QR code in the back, and you are going to need to use the RGB camera here for scanning the QR code. After that, it will come into this page, step 1. So I'm going to do this step by step. I click on start. Because it has many sensors, so you have to do this longer than the Raptor and the Otter. Just place it to the yellow position and move your hand. Okay. On the screens, now it's switching to the infrared. Now you need to calibrate the infrared as well. So after calibrate, it will disconnect the scanner and reconnect it. Okay, now it's disconnect and it will reconnect again. Your score could be higher and lower than me. It doesn't matter. Okay, now your scanner is ready for scanning. After you use your calibration board, I usually put it back in the plastic bag because you don't want to scratch any of the markers here. And it's not easy to get a replacement, I can tell you. Okay, this is a Creality Wi-Fi handle. It's compatible with the Raptors, Otters, and also compatible with the Sermoon S1. Okay, your Wi-Fi handle will come with this quick release plate. You need to pull out the rubber that conceals the 1/4-inch thread mounting hole. So you open it up, there's going to be a 1/4-inch thread. When they designed this, they forgot about the quick release plate. So if you place it like this, it's going to hit one of the edge here, and it will be difficult to thread in. You need to align it like this first, then thread in. After that, you can twist it to the correct position and tighten it. If you see here, the quick release plate is not sitting flush with the scanner. This rising edge, it will push the quick release plate up, and it will not flush with the body of the scanner. So there's going to be a few threads in there. So be careful. Then you can clip it on the handle like this, and use the cable that you used to connect with the Raptors. It will work with the Sermoon S1. And click once to turn the power on, and it will bring in a blue color. This Wi-Fi handle will work as the access point. You need to connect your PC to this handle to work. The name is the Creality Scan Pocket. You click on connect. The new firmware update will require you to input the password. You can now set the password for the Wi-Fi handle. So now the scanner is connected, and if you want to mirror your screen from the PC to your phone, you can do this by connecting to the Wi-Fi handle using the same network. And then you need to launch the Creality Scan app. Next, I'm going to click on the wireless display, and I'm going to click on this QR code scan. Tap the preview button to cast the screen. So I will tap on the preview button, and now the screen is cast. So there's going to be some lacking when you scan with a wireless screen casting. I think the lacking is about 1 second. But when you scan without the screen casting, you look at your PC monitor, there is not going to be any lagging. So it will be very convenient because you don't have to put the cables and the power supply. Okay, there are several ways that you can make a 3D scan with a blue laser scanner. One is by simply place the marker onto the object and start scanning. Second, you can make a marker turntable like this and just place the object on the turntable and start the scanning, because the scanner can see the markers on the turntable, and it will use that for tracking instead of direct apply of the marker on the object surface. Okay, let's talk a bit about the resolution. You're gonna see a real-time resolution tabs on your screen monitor. So resolution is the amount of detail that is going to be produced by your 3D scanner during scanning. For helmet this size, it has no detail. It's just a flat face with some edges. If you use 0.1mm resolution, the 3D scanner is going to produce a really large amount of the point cloud, maybe 10 million for this helmet if you scan with the 0.1mm resolution, and you're going to have an issue with the processing time and output from the software that you cannot open anywhere because the file is too big, and you can't zoom, pan, or rotate the model that you scan from the 3D scanner. This is the common mistake that I usually found from the new user. Okay, and if you want a reference which resolution that you need to use for the size of the object, I recommend that you go to this wiki page, wiki.creality.com. Look for the Raptor X tutorial. In the bottom of this article, they will place the sample object with the recommended resolution. You can use this as a guideline. The information that provided is quite accurate. For the door, 0.6. For the car hood, 0.8. For the rim, 0.5. And up to, and this one, I think this one is infrared. Okay, for the infrared, you need to select that during the fusion process. The resolution from the infrared has no presetting value. For this airbox, it has outer surface and inner surface. If I scan both surface and use 0.3mm resolution, I will have 5 million point clouds, which is quite a lot. But if I choose 0.4mm resolution, I will have about 2.6 million point clouds. And when I put it side by side, the detail is exactly the same. You need to choose the lowest resolution as possible that you can still work with your model. If you set resolution too high, you're going to stuck with the excessive amount of data that cannot be used anywhere. So I'm going to choose 0.3mm for this helmet and scan with the cross line. With the Wi-Fi handle, the speed that you are going to get is reduced from 90 frames per second to 40. So it's going to be slower than connecting it directly with the cable. So scanning is simple. You just look at the most left bar here. That's going to be your distance bar, and you also need to look at the cross line, the green cross line here. It's going to tell you that the location of the surface that is going to be scanned. Usually I would just move turntable around and move the scanner up and down to get all of the angles scanned. And if you want a smoother scan, you can remove the object and scan the marker on the turntable first. This is called global marker. When you go into this tab and choose the global marker, so you can scan the markers on this turntable, and then you can save it into a file using the export global markers function. It will track even smoother. I connect this with a cable, global marker, import, and click on the point cloud. Get about 90 frames per second. So when it's used with the cable, it will scan even faster. So once the scanner has enough data, it will turn the surface from orange to the green color. And the Sermoon S1, it has a very large field of view. So when it tracks thin shell object like this, the global marker, you can scan from one side and shift to the other side very easy. Okay, start scanning. So when I flip it to the other side, it's quite easy, because it has a larger field of view. Now I can scan all the marker. I can just place it on turntable and continue to scan for the point cloud. And one thing to note that in the Creality Scan 4, it's different from Creality Scan 3. After you done the global marker, the software will stop detecting for additional marker. It means that after you make a global marker scanned and you add a new marker onto the surface of the object, the software will not detect that new added marker. Now I have already finished the global marker scanning. If I place this object on this turntable that's full of a new marker, it will not detect the new marker. So it will only use the marker that is registered during the global marker process. Okay, so now you can see that it will only see the markers that was registered, but the marker on the turntable will not detect. You can scan both sides, flip over, and it will just know that this is the outer shell. Yeah, that's it. Finished for the thin shell scanning on both sides. Okay, one thing that I haven't told you in my first review of the Sermoon S1. In the Blue Laser mode, you cannot scan with the color. The option that you can use for turning on the RGB camera in the Blue Laser mode is disabled for the Sermoon S1, but you can still do that with the Raptors, but not the Sermoon S1. The only way that you can scan with the color is by using infrared mode. Okay, next I'm going to scan this cold plate, and I will use local detail function to scan this Firmware part with a 0.1mm, and I will use 0.2mm for the rest of the part. Okay, new scan, global marker, import. Click on the point cloud. I'm going to use a parallel line, 0.2. For this part, 0.2 is more than enough. Okay, next I'm going to use the local detail function. Click on here, and it will ask you to hold the shift key and select the part that you need special resolution. I'm going to select this part, and then it will replace this scan with a 0.1mm resolution. Click on preview, and it will erase this part. See, the part is erased. It will be rescanned with a higher resolution. Put the detail in the location that you need it. Okay, next I'm going to remove the turntable, complete the scan. Okay, so next you are going to fuse the point cloud. Click on here, and you use the 0.2. The main resolution that you use for this part is 0.2. And for the 0.1mm part, it will automatically fuse that area with the 0.1. So you save time during the point cloud fusing as well, because it has a lower resolution, 0.2. Okay, so here is your local detail result. So this Firmware part is 0.1mm resolution. This function is very useful when you need a detail in a specific area, small area, and the rest of the part is simple. Okay, let's talk about the exposure. If you look onto the right corner, you will have a preview window of the exposure. There's two tabs, camera exposure and the laser brightness. Camera exposure is the exposure setting for the markers. So if you slide down, you see that the markers is dimmer and it's too dim. And if you slide it up, okay, about this will be about the right exposure for the marker. The below slider here is the laser brightness. If you look here, if you increase the brightness of the laser, you need to look at the preview screen. If I decrease the brightness, it will not detect anything. And if I increase it just a little, you need to adjust it until it captures most of the surface. If you put the brightness too bright, it's going to give you a striking line, so you need to set it properly. If you put it too bright, you're gonna lose the surface detection, so you need to adjust it until you get a lowest brightness and maximum capture area. With this version 1.1.17, you can just click on here, auto brightness. It works very well with the Blue Laser mode, and I recommend you to use it because it gives the best result I have tried in many surface conditions. So when you have a high contrast object, black and white, yellow and black, it will automatically adjust the brightness when that detects the color of the surface that you are going to scan. So this is very useful, and it functions very well, except for the infrared mode. Okay, let's talk a little bit about the infrared scanning. In the infrared mode, with this version 1.1.17, you're gonna find the issue where the automatic exposure is underexposed. So let me show you. Now it's in automatic exposure mode. Wide angle depth camera is going to lose the track, going along like this because it's losing the track. Now it's losing the track here. That is because it's under exposure. You can adjust the brightness by clicking on this button, and you need to adjust it manually. But if you increase the brightness manually, you see here about 600, you will get a more capture area. So now it can track. You can see that. Now I can track this chair after I manually adjust the exposure. Okay, so this is a comparison between the scanning mode and the resolution. In the front, it was scanned with a 34 line at 0.3mm resolution, and in the back, it is scanned with a single line at the same resolution. So you can also use a single line to scan a solid face object, not only the deep pocket and the hole, and you can see that it gives very similar result between the 34 line and a single line. So when you switch between these two modes during the scan, it will not deteriorate quality of the scan at this resolution. And if I move to 0.2mm, in the front is the 34 line and in the back is the single line. You can see that it gives higher detail than the 0.3. Between the 34 line and single line, they give a very similar result as well. So at 0.2mm, when you switch between these two modes, 34 line and a single line, you will not deteriorate the quality of the scan. Okay, now let's move to highest resolution, 0.1mm, 34 lines and single line. I can see that 34 line give higher detail than a single line at 0.1mm, just a little bit. If you are using a 0.1mm resolution, which is you shouldn't do that with 34 lines, the single line will deteriorate the quality of the scan a little bit when you're switching between these two modes. Alright, and if you compare 0.1mm, this one is from the 7 lines and this one is from 34 lines. You can clearly see that at the same resolution, a parallel lines gives a better surface quality than the 34 line at any resolution. So if your object is not too big, you can put enough markers on it. 7 lines will produce a better result than 34 lines, but we use 34 lines for a medium to a larger object because it scans faster and has a larger projection area. So, and if you switch between these two modes at this resolution 0.1mm, and the 34 lines will deteriorate the quality of the scan because it has a worse surface quality than the 7 line. So if you want to use between these three modes, I would suggest that the safe resolution will be 0.2mm. This wouldn't deteriorate the quality of the scan. And this is same for the Raptor X and the Raptor Pro. It's a bit of disappointment when they make a fast 3D scanner, almost twice the speed, but they keep the same frame limit. So you have less time to scan with the S1, only about 7 minutes for one scan. So what you're gonna do, this part I split the scan into 2 scans, so I have 14 minutes. And second, you need to move very fast. If you move fast enough, you can complete the scan within the frame limit. They should have increased the frame limit in the software when they make a faster scanner. I'm going to show you how the single line laser mode works with the S1. This all has a diameter of about 4.5 centimeters and the depth is 9 centimeters. If the depth to width ratio is about 2, the S1 can easily scan even though the surface is black color and without a spray. But if you use a spray, the ratio will be higher and it can scan deeper. I'm going to move like this, up and down, and with 90 frames per second you need to move a bit faster. It's quite difficult to set a camera. Just do like this and then you move it. You can also scan like this and slowly move the turntable. I think this method is slower than this method. I mean, if you scan it like this, it will be faster. It gives the same result. Let me check. Yeah, that's all I think. I'm going to use a single line to scan the inside of the pocket. This pocket like this. When I use Raptor Pro, you can't scan it. It won't be captured inside of the pocket. So I need to repair it. I need to use Clay software to repair the model. But with the Sermoon S1, you can make a complete scan of this pocket. As you can see that now I have already spent 20,000 frames because with a single line it also scan in a very fast speed. You have 40,000 frames for one scan. Now I have already spent half of the frame just to show you to scan the tube and this part of the pocket. See the single lines use a lot of your frames. Okay, next I'm going to scan this wall of the tube. It is blocked by this wall, so it cannot be scanned with the conventional laser lines. But I can do this with the single line. Let me show you. So if I move my scanner like this, I will be able to scan past the center of the tube. And if I do this in both sides, I will erase all the blind spot of the scan. Because the single line has a special projection, it's going to wrap around the circle, more than half of a circle. Okay, I move to the other side. It's not tracking. I need to track it from the other side. I didn't use global marker. Maybe you don't see this because the wall is blocking your view. See here? So it's all scanned. Okay, next I'm going to show you the capability of the single line for scanning a deep pocket like this without using the spray. So I'm going to show you with the cross line first. That is captured slowly and it won't turn into a green color because it's deep inside and the wall is turning against each other and it reflects the light. So the 34 lines cannot capture this. But if I switch to the 7 lines, see here, 7 line can capture. You can see it's capturing the lips. 7 line can capture smaller details better than 34 lines. But the best part is single line. The single line can scan deep inside of the pocket, but it's not going to be fast. See, it slowly erases the unscanned area. In the orange color, it slowly turns into a green color. So you can scan in a box like this without using the spray. The part that cannot be scanned with the 34 lines or the 7 lines can be scanned with the single line. It's faster. 7 line is 7 times faster than a single line. A flat face like this, 34 lines will scan very quickly. You see here, just a few seconds, and it fills all the area very quickly. See, I will always use 7 lines for scanning the ribs. It's faster. Anything that is about 1 centimeter in a strip, 34 line cannot get in, but 7 line can, and it's faster than a single line. Okay, next I'm going to do a full scan of this part, but I will use a spray because I don't think that I can make it to the 40,000 frame limit without a spray. Spray will help the 3D scanner see pocket deep inside, and you will see in a minute that even 34 lines can make a complete scan inside this pocket with the spray. But without the spray, I need to use a single line to collect the missing data, and it consumes the time that I need to scan other pockets and the hole. So I won't have enough time without a spray to scan all this. Okay, let's compare the scan from the Raptor Pro to the S1. The S1 is on the right and the Raptor Pro is on the left. The Raptor Pro was scanned with a 0.3mm resolution because that time I have a time to scan this in 40,000 frame limit because I don't have to spend time scanning with the single line because it doesn't have single line. But for the S1 I need to use 0.4 to saving the time because I will hit the frame limit if I use 0.3mm for scanning this part. The embossed letters from the Raptor Pro has sharper, has more detail. That is because it was scanned with a higher resolution. But the rest of the part, you won't be able to see any difference in the resolution. And this one, I think, is about 6 million points, and this one only 2.3 million points. Size of the model is quite different, and if you put this in a CAD software, you're gonna see a difference when you orbit the model in your viewport. Let's check what's the difference between these two scans. Okay, one I can see here. There is a part that it was not scanned with the Raptor Pro. I can't scan it with a 7 lines laser. It can't get into this gap, and this one, the S1 does better. And if you look at here, the top of these ribs is perfect, but the one from the Raptor Pro, it cannot scan the top of the ribs, so it creates a random mesh shape to fill that a hole, this edge here, along this edge here, that's going to fit into the filter. The Raptor Pro has an incomplete scan, while the S1, all the edge here is complete. The scan from the Raptor Pro has a lot of missing data because a 7-line laser cannot scan this, while the S1 I can swipe it with the single line. The rest of the part for the inside of the box look similar. Let's move to the top. Okay, if you look from the top, you can see the difference of the resolution setting. 0.3mm, 0.4mm. The embossed text look quite different, and there are marker defects on the S1 because the new Creality Scan software, the CR4, has an issue when removing the marker. There's some leftover marker that cannot be removed. I have already addressed this issue to Creality, and they said they are going to fix this, but with the previous Creality Scan 3, is marker removal is very effective. Okay, so what else you see from the top? The hole from the Raptor Pro, it's not deep, even though I use a spray to spray inside the hole, but the 7-line cannot go very deep. Okay, this is the deepest that the 7-line can go. You see here, this is the deepest, maybe about 15mm. That's from the Raptor Pro. And for the S1 single line, it's go all the way in, and it has a complete circle for this tube. So the depth is 9 centimeters and the width of the hole is 4.5. This is very difficult part. This bottom of the tube, it is blocked by this wall, so it's not possible to scan with any scanner that I have. So this is not scanned. The software fill the mesh with a flat face, but with the S1 I can completely scan this tip, so it's quite perfect. Okay, here's the back side. The Raptor Pro has a small marker defect here. This is the S1. It has so many marker defects. 1, 2, 3, 4, 5 marker defects from the S1. So the Creality need to address this issue. And if you look into this tip, you see that it has a very clean scan all the way to the bottom for the S1. But for the Raptor Pro, rebuild the mesh to cover the hole that it cannot scan. It looks like this. The pocket is clean and it's go to the bottom, while the Raptor Pro, it has some rebuilt mesh to cover the hole. If you look at the pocket on the top, the S1 go down to the bottom. And this one is built. This one is actually go deeper. I think it's filled with the mesh and it feels very good. It looks like it's correct surface, but this is wrong. The actual one is deeper than this. There's a small gap here, the hole, but with the Raptor Pro, it conceals the hole with the mesh. So we have a defect here inside of the pocket from the Raptor Pro. And for the S1, yeah, all the pocket is scanned. The Raptor Pro, it cannot scan this pocket at all, so it's filled with the mesh. But the S1, it can scan to the bottom, and you can see that there's a marker defect here and here, while the Raptor Pro has no marker defect at all. That is because the software Creality Scan 3 does better when removing the marker than the Creality Scan 4. So using the S1 with a single line laser is give an edge for making a complete 3D scan model. If they fix the marker removal, I don't even have to do a post-processing. I think having a single line laser is an advantage because you can scan almost anything without post-processing the model. Alright, thanks you guys for watching. I'll see you in the next video.